This is round 9. LeetCode under an hour. Let's get started. Okay. Timer and let's go. Apply operations to make two strings equal, giving two zero-indexed binary strings, S1 and S2, both of length n and a positive integer x. Okay. You can put any of the following operations on string 1 at any number of times. Two indices, I and j, flip both of them. Cost is x. Okay. Choose an index I such that I is less than n minus 1. So it's not the last digit. Sure. And flip both si and I. Okay, so flip it and it's in the next one. Cost is 1. Okay, sure. For the minimum cost needed to make the strings S1 and S2 equal, or return -1 if it's impossible. Oh, the flipping character means 0 to 1, vice versa. Sure. Okay. Okay, so an important point to note is going to be that the flipping operations will flip I and j. Okay. Okay, so important part to know is this, which says you'll flip both I and I plus 1, so it goes from left to right essentially. So I'll flip this and this. Or I can flip choice 2 of them. Interesting. So currently what I'm thinking, right, is I have two strings. See, what is this doing? X is less than 500. Sure. Okay, so to read through this example, I is equal to 3, so 0, 1, 2, 3. Second operation, so flip these two, right? And do the next one. Okay, so given that it needs to be min, I'm thinking some kind of DP table. I don't think there's a way to do this greedily. Just off the top of my head. If there would be, it would be something like start from the left, flip it, and then assume everything else to the left is flipped and keep moving. But that does not seem to be right. So anyway, some kind of DP operation. Let's say okay. I want to get the minimum cost. So DPI equal to minimum cost for what? Oh, I don't know. It could be for index 0 through I to be the same. But the fact that ij doesn't process linearly, other than left or right, you can put it anywhere, is really throwing me off my game. Not sure. Okay, wait. What if you form a bitwise or XOR, right? This will result in 1 in all the places that need to be flipped. Which gives us a rough understanding of how exactly or where exactly we need to do some operations. So given that, right, let's say now I have a string of 1 0 0 1 0 1 1 0 0, right? If I see a string of 2 1s, I can process this pretty much left to right. If let's say I'm processing the string. If I found a 1 that's alone, then I add it to some kind of list stack something, essentially so that I and j, I could have like an I and j that I can use for this operation. And if I see 1 1 together, then I just flip these 2 bits using the cost for 1. And if it's an odd number of individual ones, so let's say this is a 1, that's impossible. Nice and easy. So let me just write that down somehow. Iterate through resulting string if count number of ones, if pair of ones cost plus equals 1, if 1 on its own cost add to a count, if the final one alone 1 count is just say odd, return 1, else return cost plus x times alone count over 2. Right? That makes sense to me. And now I just have to actually implement it, which is a little annoying. I'm going to manually perform the bitwise OR solely because it's easier to understand for me. And I don't really remember the syntax for and because of the string is the main reason. So anyway, XOR is equal to, let's call that, right? So for let's say char1, char2 in zip, str1, str2, if char1 is equal to char2, sort out append 0. Oh, string concatenation is pretty slow actually. Let's make this a list. Yeah, 0. And then we'll just convert it to a string. Actually, we don't even need to convert it to a string because it's not getting returned anywhere. Else x or dot append 1. That's enough. That's our XOR. So now for lm in XOR, if let's see what I say. So if it's say the cost. Okay, let's say alone is equal to 0. Cost is equal to 0. For lm in XOR. Or actually let's do I, comma lm. Enumerate. There we go. If lm equal to 1, then I should do for I, because I'm going to be moving I more in irregular intervals, so I just want to, I'll just, instead of doing a for, I'll just do a while loop where I say while I is less than when XOR yeah. So if lm is now XOR I, if XOR I, or I should say, if I plus 1 is less than when XOR and XOR I plus 1 is also equal to 1, then let's do I plus equals 2. And then this means there's a pair, right? There's two ones that are right next to each other, like these two. So that's why we move I by not 1 but 2. And let's see here. So less than that XOR, XOR plus 1 equal to 1. Then we have to do cost plus equals 1, because we assume that we'd change one of them to we'd change these two adjacent values using the second operation, which is always going to be 1. Okay. Else, that means the current one's still 1, and either it's the last one or the next one isn't 1, which is fine. We'll just say alone plus equals 1, right? So then we go through the whole thing while doing that, and we say if alone mod 2 is equal to 0, return that's nice. Okay, return -1 because it's impossible. Sorry. Do 1, then return -1. Else we return cost plus alone divided by 2. I guess it should theoretically be integer division, but it's guaranteed to be even, so it's fine. Times x. I don't think I need parentheses, but make it look cleaner. That should, oh no. I did not mean to do that. Please keep my code. Nice. Okay, wonderful. This seems right to me. Let's try to run it. Interesting. Oh, where is this? str1, str2. Oh, it's s1, s2. Yep, I have to set I equals 0. Yeah, that makes sense. I don't know why that took so long. Oh, I didn't add I++. That, see? Sloppy coding, really. R plus equals 1. And then that's only if the if, else, I plus equals 1. Yeah. Should work, okay. Oh, 4 point. I need to cast isn't in because of division. Yeah. Let's just do that. Look at that. Submit. Oh, interesting. Let's try to figure out why. Okay, so give this example. 0, 0, 0. We're gonna get 1, 0, 1, 1, 0, 1, right? So obviously right here you'd use x equals 6, okay. Right here you'd use the +1 because you want to just flip these two together. And then right here you would use the whole, or it would be technically here and here, or here and here, and you'd want to use the x equals, you want to use this thing essentially. Whatever it was, I can't find the, whatever, it doesn't matter. You don't use this. But the problem is that I think it's actually easier if you flip, in this example, all of them, which would be 1, 2, 3, and then, oh, wait, what are they doing here? They use this, essentially they use this operation 4 times to somehow get the same one. How? I guess my greedy methodology doesn't really work because I was planning on because I really just look for the pairs and then I flip them. But apparently it's not a good strategy. If I flip 0 and 1 together, be 1, 0. Then you flip these two and it's 0, 1. Right, and you get 0, 1, 1, 1, 1, 0. So you use 2 more and they're all 0, 0, 0, 0. I see. Okay. Now I see how it's done, but how do I go code to do that? I think I have to implement some kind of, because the greedy strategy just won't work here. Which is unfortunate. It was really simple. I liked it. I still think a bitwise XOR is the right way to go. So given that XOR, right, this one I need to change. I have to somehow, I mean, DP is the main idea. How do I get it to work? I mean, given that I have an XOR, and it's only one string, right? I can say like a 0 through I type of thing. So ensure that all the values 0 through I are equivalent, or the string 0 through I. So let's say, for example, it would be min cost. I said DPI equal to min cost to flip digits such that S1 0 through I and S2 0 through I equal, right? I can do the return -1 by just counting all of the ones now this time, instead of doing this whole flipping stuff. Which I'll probably do before the DP, solely because it just makes more sense. Sure, just to save time. Not because it makes more sense, it's just faster. Let's move some stuff around real quick. If I count 1, 2 is equal to 1, return -1. Nice. This will now be I count. Right. That makes sense to me. Let's move this down to here. I'm gonna comment my code a little bit just to make it a little bit cleaner. Okay, now back to this DP. Alright, min cost float just have to set S1 0 through I, S2 0 through I are equal. So how do I do that given I have an XOR? Well, okay. So an important point to take note of is that it is possible that these substrings could be not possible to flip. So it could fail this condition, despite the whole string being possible to flip. So due to that, what I'm thinking is use a negative for the cost if it is impossible. And this would allow me to say if, let's say I'm doing DPI, right? At DPI, only consider from DP0 to I-1 all the I values that are negative, less than 0. And then from there, I pick the min value depending on what operation I'm using. I think that makes sense to me. So start writing that out actually. So DPI, okay, let's write it out informally in a comment. I don't want to do anything else right now. DPI equal to, actually no, let's start writing stuff out. If XOR I is equal to 1, else XOR else DPI is equal to current min. So essentially that'll be the store while I'm doing this whole DP array, I'm going to store anything that the lowest flipping value. No, it's gonna be the most recent actually. Ignore that. It'll just be. I'll just go backwards and say the first value. Ooh, this current min is actually more puzzling than I thought. The last one, essentially. So let's do last one cost. Min last one cost. Right? Oh, you do need, wait, no, you do need to perform operations if XOR is 0, right? Because, wait, no, if XOR is 0, that means everything's fine. They're the same. So yeah, this is tentative, I'm not very sure. DPI, if XOR is equal to 1, that means there's a difference. How do I solve this difference? Well, the minimum of first thing I gotta check is if XOR, well, if I minus 1 greater than 0, and XOR minus 1 is equal to 0, then I would make it, then I would just increase by 1 because I think the cost X is always greater than or equal to 1. Yeah, so you always want to do, in this situation, you just always want to do the flipping thing, the double flip, the adjacent flip, I'll call it. In which case, adjacent ones, this is, in this case, we would just take the if, we take dp of I minus 1, multiply it by negative 1, right? This could mess up because what if there's 3 i's in a row? I'm still very confused, if I'm being honest. That would be a 1, 0, 0, 1, 0. I'm not sure what the optimal strategy to solve this would be, or like solve in general. How do we solve this problem? So I'm struggling a bit to make this DP solution because I don't have a real solution in my head. Dang, I really thought I had that greedy strategy. Okay, let's think. flip 1, 1. Okay, I'm going to try to compute the XOR for this, because I don't know what the real difference is between these two. Right, that would be 1, 0. So the third character is the same, so 0. Fourth character, just different, so 1. Same. 0, 1, 2, 3, 4. 0, 1, 2, 3, 4. Yeah, those are the same. 0, 1, 2, 3, 4. Okay, so 1, 0, 1, 2, 3, 4. And this would be a 1. Then it would be a 0. Then it would be a 1. No. Then it would be a 0, obviously. And then it would be a 1. And then it would be a 0. The rest doesn't matter. Alright, that represents the first example. Nothing is next to each other. This is the example where I failed. Interesting. Let's see. It's a niche case. It's tough, I will say. I don't think I can code in like an exception where it goes like, if you see double ones, but then also there's a 1, 2 away, and another 1, 2 away on the other side, and flip those first. Or maybe I can, okay, this XOR string, right? Maybe I can process it such that I can somehow group all the ones together. I don't know, that seems... Okay, wait, hold up. How many moves would it take to move this, to move all these ones to the front, right? Take 1 move, another move, so 2 moves. Put this guy next to this guy. Take 1 move. Put this guy here. 2 moves. The number of characters in between. Take 1 move to this guy here, 1 move to this guy here, and then all 4 of them take 2 moves to flip them all to 0. I can use this mimicking or moving ones gimmick. How? Can't just move it to the left or the right. Because in this example, if I move all the ones to the left, it's not going to be 4. I think DP is my solution. So because I can't, there's so many counterexamples that like I have to let something kind of automatic solver do it. Consider all possibilities. But how do I consider all possibilities? Well, given a string, XOR string, right? I can either, yeah, let's say I have an XOR string. I can do a few things. Or substring, right? DPI. I consider all of, in order to get the min cost, I consider all of the prior substrings. So all the prior DP values that have the same odd even value as that DPI as a number of ones. So for example, if DPI is 3, as it has 3 i's, I can consider DP1 when I'm building off of it. Or the DP where I is equal to 1. So given only those DP values, what can I do? Well, I can either go to the most recent, right? The one with 2 less ones than this guy. And depending on placement, either use the +1 strategy or +X. That's option number 1. Option number 2 is I can consider the one before that. I'm thinking about this all wrong, right? Rather than thinking of it as like separate type of DPI values, there's one DP table, and then process it left to right. This XOR string, I can either flip it. I can assume now that there's an even number of ones. So I can either flip for the XOR string 1 itself and the next value. So the next XOR value would be 1. Or process one by one. No, that doesn't make sense. The XOR can either flip it and push the one down the line, right? Let's say I'm right here. Or that's right, let's say I'm right here. I either flip, say I is equal to 2 to deal with this 1. I can either flip it I don't know. If it has the next one, is 1, I can either flip it, in which case the cost would be plus 1, or I can choose not to flip it and leave it be, I guess. Then move on to the next one, then flip it, leave it be, and I can flip that one. Okay, I can flip the 2 insides, and then the 2 outsides, right? And that's the same as the 2 outsides and the 2 insides. So I can flip this, and then I can flip these 2, and then I can flip these 2, flip this, and then flip these 2. Okay. The fact that I can process that, I am intrigued. I don't think I need DP anymore, to be honest. I'll leave it there for now, but I think I can modify this a little bit. Instead of right here, where would I even add X? Alone, right? Instead of here, where I assume that if it's not automatically next to someone, then I add X. Maybe I can try this pushing strategy. But I need a way to consider if that's worth it or not. There's the brute force methodology, which would be, no, there needs to be a mix of alones and pushing it. Let's consider that pushing strategy for this, right? For this guy, I can either flip him, flip both, or leave it, because there's an odd number. Okay, here's what I'm thinking, right? You can either flip both these 2, or leave it, because there's an odd number of ones. Let's say you automatically flip both if there's an odd number, right? If there's an odd number, you flip it because you're trying to push it away. So you flip, cost 1. For these 2, there'll be 1 here. So you flip, cost another 1. So you're done with this, because this is both 0, 0. Now you consider these 2. It's a 1, 1. Wonderful. So you flip them both. Or, since you've now reached your second one, you could only flip these 2. And you compare them in with that, and that'll just clear you for this entire thing. What? Oh, that's just DP. That's just DP again. Oh, okay. I now have a better way of doing this. So, how do I write that down? What does that even... I bet that explanation that I just said doesn't even make sense to anyone other than me. That whole flipping thing. So assume you clear it up to I. Main cost flip is such that XOR string is cleared up to I. Take into account number of i's. No need for that. So here's what I'm thinking, right? While I is less than my XOR, or actually I just need dp equal to 0 times n. Okay, wonderful. Wait, n plus 1. Yeah. So let's leave it at n actually. And then for I in range 2. While I is less than n. I do think I will only be incrementing by 1, but just to give myself more flexibility. And it was already defined anyway. Don't need this cost variable, which is the dp arrays for. If, so I need an I count. I'm probably going to merge these two once I'm done, but for now, I'll leave it separate. If I is less than n, while I is less than n, if I count mod 2 equal to 1, and I can mod 2 is equal to 1, right? Then you just want to flip it and just ignore the consequences for now. dp of I is going to be equal to dp of I minus 1 plus 1. And then we say XOR of I plus 1 is now equal to 0. I have to also say that and I is less than n minus 1, else turn -1. So I basically have the code for this built in, but whatever. Anyway, so you assume that we're flipping. So flip it, and then we change the XOR such that now we have to deal with the next, because it just gets pushed on. So it's been pushed on in this case. And that's it. We're done worrying about it. So dpi is equal to dpi minus 1 plus 1. Right? Perfect. That makes sense to me. I might have to do some index fudging because strings start at 0, obviously. Whatever. Right, so that's that. Alright, let's be elif actually. Elif I is greater than. Actually, wait. Rather than doing it elif, let's leave it at else. If I is less than n minus 1, then we do this. Else turn -1. else, this means now that this thing is even all of a sudden. This is where the DP stuff comes in. We say, okay, so either have I checked if I haven't checked if XOR is equal to 1. So if XOR equal to 1, so let's say in this scenario, and I is less than n equals 1, yeah. Push it down, so XOR is equal to that. Just for clarity's sake, I think I'll say XOR 0 or I is now equal to 0. It doesn't really matter because I'm never accessing that value again. But anyway. Yeah, so push down. Oof, timer's coming close. That's not good. Anyway. Right, that makes sense. And then, or, let's say it's here, so now it's the same thing, but all of a sudden, I'm on the second one. So now the I count is equal to 2, so there's an even number of I's. Well, that means that, according to my DP, I think that means there has to be, because you're always going to have an odd before an even, so that means there must be a 1 before it, because this code right here pushes it down to the next even. So we can either say dp I is equal to the min of, one option will be dp I minus 1 plus 1, or you can go back to the last, whatever this original position was, and say whatever this guy, so essentially this dp I minus 1, and then add x, dp of question minus 1, call it original I guess, original I is 1 plus x, right? So either do you want to push it all the way down and flip it, or do you want to just isolate them and flip it? That makes sense to me. I have to set original I here though. This should be a flip rather than setting it automatically equal to 1, because what if it's already 1? So this should be flip. Then other than that, we're just going to say original I is equal to would now be equal to this I, and it'll be stored. And then when it comes to here, it'll say, oh, I remember original I. And then it'll compare. But there's a problem here, I think. Like, let's say there is a 1 0 0 1 1 0 0 1 1 or 1, right? Let's take this guy, push him all the way down, and say, do we want to flip these two together when he pushed him down to here, or do we want to or do we want to just flip them isolated, right? Let's say we do we ever flip these two and then leave this? No, right? So that doesn't matter. Okay. I'm not sure if that's optimal, but we're just going to ignore that for now because time is running out. Okay, original I minus 1 plus x. Blah, blah, blah. Sure. And then if XOR I is equal to 1. If it's not equal to 1, then whatever. I don't care. We just gotta do an I++. So I think that's fine. I'm gonna change this to a for loop actually. For in range n. Does n exist? No, it doesn't. God dang. Len s1. N is len s1. Did I use n anywhere else? Probably did, but I cannot see it in a quick skim. All right, and then we return dpn. Oh, I gotta fix the indexes. Damn. Return dp of n. Okay, now let's do some quick index fixing. We're gonna do an n+1. So then I will start at 1. And then wherever I is referenced, wherever I is referenced, let's change this to index actually. So XOR, it goes from 0 to n, which is good. So it goes index. If the index is fine. Originalize fine, because I'll be equal to index. So we go to index. So we also index. So be I can do the flip thing. Okay, anyway, that's a flip. This would be index. I could just leave it at I, to be honest. Or let's actually, I don't know how many I's there are. So this is an I, so we're gonna make it I. Okay, we'll leave I as the DPI, right? Where else was I used? Here. Okay, that's fine. So then we'll just, right here, we'll just add an I plus equals 1. I plus equals 1. Boom. Should be fine. Let's run it. I doubt this works, but it would be amazing, and I would still fail the time limit. Unfortunately, the time is up. Let's hide this. Let's go to stopwatch. And we'll start a stopwatch in overtime. Very sad. Okay, I know I'm close. Still fail, but damn. Right, and I can keep this code for sure. Probably will do that before recap 1, but output 0. Yep, definitely a bug in the code somewhere. Okay, let's print DP before we do anything. So it should be 0, 1, 0. I don't think that's right. Oh, wait. +1 plus x. That's correct. DPI minus 1. Okay, so starting here, right? This is the full string. This is just this index, this 0 value. Match it up to. Where are you? Damn. Whatever. No, wait. Where's the string? It's right here. Okay. So pretend to move it. It should be 1, 2, 3, and then back to 1. I don't know why it's 1 here and then 0 here. Why would it go back to 0? If. Oh. Wait, no, it should flip back. Index should increment here. Then this should be turned into a 1. So when it checks XOR index again, it should say true and it should go back in. I'd love to debug this, but it's a premium thing only. So XOR index is equal to 1. Count 2 is equal to 1. Print TP, print XOR. That's not right. I think it's this. And then this. Yep. Okay. all of these are going to be turned into comments once I get the solution and submit it. You guys run this now? Right. Sure. Okay. DP would be 0, 0. XOR is 1. Nice. Difference detected at index 0. Oh. Is that the problem? No. Because I is starting at 1. Well, index is starting at 0. So XOR of index. No, that doesn't make sense. Yeah, difference detected index is fine. The difference detects, but the odd number doesn't, because I never incremented I count. Sometimes things are annoying. Okay. All right. Wonderful. Now, how do I prevent a double trigger because of this whole XOR stuff? I think I can just, well, if I push it, I'll just undo it. So I'll say I count is equal to 1. Because we're pushing it from, we're taking the one that we originally had, pushing it to the next one. So we'll remove it from our count. Or push it and deal with it later, essentially. Run. What's happening now? Okay, odd number of ones, not last num, sure. Difference detected at 0. There's an odd number of ones, sure. It's not the last one, sure. So, boom. We flip it. So we just flip these two to make it 0, 1. Nice. Difference detected, it's an odd number. Blah, blah, push it again. Boom. Nice. Now difference detected at 2, which is 0, 1, 2. It's an odd number of ones, not last num. Boom. Wait. 0, 1, 2. So difference detected at 2. This all works fine. So there's a difference detected at 2. 0, 1, 2. Odd number of ones. Sure, that is true. It's not the last num. Sure, that's true. So you flip this. I think I have to add this whole code in here. But anyway, why does it not run that code? Let's check. Okay, difference equals 2, but the next one is a difference. Why does it just increment by 1? No, I never changed this. That was dumb. Very dumb of me. Okay, anyway. Obviously I know that this now has to be different. So original I will mean it with index here. Does that make sense? So essentially, right here I check if the next num is a difference. So if there's a 1 and then another 1, I can, like shown here, versus if it's the same. So if it's the same, then, well, I'll just, this one's already zeroed out, but I'll make, if it's right here, right? So I'll make this one a 1 and then zero out this guy, then increment the cost dp by 1. Then make sure I remember. That's not the original though. Finding the original I will be a little bit annoying. Could do a brute force type of thing where I loop through the entire array, build a stack of all the ones, and then find the, and then maybe like binary search it. But that seems like a lot of extra work. I'm not in the mood for extra work at this moment. I can check if original I was -1. Right, if original I is equal to -1, then I set original I to be equal to the index, right? Otherwise, that means that the one that I'm dealing with in this case has already been pushed. How do I know that? Because original I will be reset to -1. Somewhere in these else statements is my current thing. Or maybe here, right? Because I've dealt with the last original I can now set original I back to -1. -1. So it should never go here. So I'm just going to hit run. Next time the same. Okay, so this is fine. 1, 2. Oh, what happens here? Oh, it does go here apparently, which is not good. So anyway, next time is a difference. Difference detected at 2. So 0, 1, 2. Difference detected. Yes. odd number 1, sure. It's not the last num, sure. Next num is the difference, sure. So index plus equals 1 equals 0. X over index plus equals 0. So this one's already zeroed out, so now we're zeroing out this guy. Perfect. And then the dp is equal to either the last one plus 1 or the original I, which I never actually printed. Let's assume it's 1b1. Oh, it'd be 0. Okay, so original I refers to an index, but it's accessing something in DP, in the DB table, which is all plus 1. So I think that's why I have the negative 1, though. And the original I was the original, where did I set it? Here, right? So original I is the original place in XOR indexing where the 1 was, right? So it'd be 0. And in the DP table, it should access 0. Because you want the one behind what we're considering. So it would be just original I. I don't think that'll fix it, but we're going to. That was really dumb. I don't know why I did that. There we go. Anyway, blah, blah, next time the same. Sure. Question is, why is this still running? This test should theoretically give me more insight on why that's happening. So next time the same, sure. So difference detected 2. The number of 1s, not last num. Next time is a difference. Original I is equal to negative 1. Oh. What? Why is it equal to negative 1? That's weird. Next time is difference. Original I. I don't know why that's happening. It should be negative 1 here. It's equal to negative 1, so it should change it to the index. What? Did I spell it wrong? Oh my god. So the 0 carries over, sure. What is the x in this example? It's 2. Damn. So yeah, so instead of flipping it, moving it all the way here, which would be 1 cost of 1, cost of 2, and flipping both of them together would be cost of 3. It picks 2, which is good. I mean, XOR would be 0, 0, 0, 1, which is nice. So it's going to ignore that, go to, that's going to be fine. Oh, so okay, so instead of just skipping over, it's just got to carry that value over, and then it'll be fine. Let's close this. solely because this should never happen. So if it happens, there's a bug in my code. Else, right? So if XOR index equal to 1. If it's not equal to 1, then we just want it to carry over. So dp I to dp of I minus 1. So 2, 2, 2, and then difference detected at 5. So 0, 1, 2, 3, 4, 5. Nice. So original I, which should not be equal to 0 here. Why is it equal to 0 here? It should be equal to this guy right here, which is 5. Original I. Difference detected is index. So why is the original I setting, despite setting to index, why is it setting to a 0? It should be setting to 5. What? What's happening, bro? Does the original I not set back to -1 somewhere? What? Why is it not setting back to -1? Okay, next time is a difference. Original I is equal to 0, and then original I is equal to 0 again. Oh my god, it's an... The code is so simple. I just kept screwing it up. What? I'm so confused. How? Why? Yeah, let's have something to debug it by. Okay, so 0, 0, 0, right? Okay, what's the correct answer? The correct answer is 4. Why does it sort of say 1? What's the DP table at the end? It should never be going back down. It should never go back down. Never ever. Why is original num -1 when next num is the difference? Okay, so this XOR. We got 0, 0, 0, 1, 1. Oh, for the when's the last one? I see. Okay, that's probably the issue. Not last num. Do I have anything for last num? I do not. Okay, wait, hold up. Next number is a difference. Original I would be 5. So keep going here. Difference detected at 9. So 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. All number of ones, which is correct, not last num. Sure. Next num. So then we just move on. Wait, it doesn't loop around. Yeah, not last num. Next num is the difference. Original I is equal to -1. So if it is the original, oh, so my code doesn't handle organic 1-1s. Let's add a quick one here. Okay. There we go. Oh my god. Expected 6 got, output 6 got 4. Okay, how do I do this in 4? Well, this is the XOR, so I can go 1, 2. And then together. That's 4. How's my code not handle that? Can do these two. My code can say, we'll do these two together. Just 2. And we'll do these two together. Just 2, and we'll do these together, which is 6. It doesn't handle it doesn't skip anything over. That's a fundamental flaw. And it's way over time, so 1 hour 30 minutes I'm calling it. It's definitive fail. No overtime, nothing could help it. But I do think I'm very close to the solution, but oops. I think I'm close to the solution. It's just something ain't right. Just some way I'm processing it. It's just not right. Anyway, that's it. Very unfortunate.